It is Thursday, February 20th. It's our second day of remote learning. Unfortunately, I can't give you a day off. So we're doing another really important lesson. Please make sure that you watch this video. There is a warm-up embedded in it. If you can print off the notes, that would be best. Otherwise, copy down what you need to copy down, but for sure copy down the examples. You're going to be submitting a copy of your notes to an assignment in Canvas as well. So I won't have tutoring today, unfortunately. Your Neptune Navigate is still due by the end of this month. We're probably going to take our quiz on Monday. So I'll finish up tomorrow and then take our quiz on Monday. And all the other stuff still applies. We're still having our test on March 4th, and all your assignments and your Delta Math is still due March 3rd. So obviously you can't get a warm-up sheet, but get a piece of lined paper and you're going to go to Canvas. You're going to find week 7 and find this assignment titled 220 Delta Math Warm-Up for radicals and discriminant review. So radicals, so basically simplifying radicals. If you have something like the square root of 28, that can be simplified to the square root of 4 times the square root of 7, which is 2 square root of 7. So we need to practice that because we're going to see that a lot in the future, very near future. And also a discriminant review. When you have the quadratic formula, you have this thing called the discriminant. You did a lot of this, hopefully in Math 2, where you have b squared minus 4 times a times c. And you need to be able to simplify underneath that radical sign. We have to do it without a calculator. So obviously you're at home, you'll probably use your calculator, but just know that we do it without a calculator. So go ahead and pause this video, take care of that warm-up. Please try not to use Desmos or calculators so you get the true experience, and then come back to this video for the notes. All right, our learning goal today. We already know how to factor polynomials. You learned this last year, how to find square roots, solve using square roots. And you also learned in Math 1 and in Math 2, you've practiced using the quadratic formula. So we're going to be using all of those things today to solve polynomial equations. So this is straight up review, but it is harder than what you've done in the past. So here we go. So solving polynomial functions can be done in 4 different ways. And today we're just focusing on real number solutions. That means rational solutions and irrational solutions. Rational solutions are anything that can be written as a fraction, so whole numbers, fractions, decimals, and irrational solutions are something like the square root of 2, which is irrational. We're not going to get into imaginary until tomorrow. So there are a few ways that we can solve polynomials. The first one is by graphing. We won't be using that method right now. We can solve by factoring. That's where we're at right now. We know how to factor, so we can solve by factoring. We did a little bit of that in Unit 2. We can solve by square roots. So when we can, we will. And then we can also use the quadratic formula. The quadratic formula does have some limitations. We can only use it if we have a quadratic. That means anything with a leading term of something squared. So we learned this in Math 1, Math 2. Solutions occur when the graph crosses the x-axis. So if we're looking at a graph, that's where we can find our solutions. They're also going to be called x-intercepts, zeros, and roots. So if they say find the roots, they're saying solve the polynomial equation. X-intercept, zeros, all of those things are just solving or finding solutions. What you're going to find later in the unit is that you can tell how many solutions the polynomial has, which will be really helpful. So we're going to practice these 3 ways. We are not solving with imaginary solutions today. So the first method that we're going to use that we're already familiar with is solving by factoring. Again, only copy down what it is that you think you need to know, but for sure copy down whatever I write, you write would be the best rule of thumb. So after we factor, which we've been doing almost since day one, we can solve, if there's an equal sign, we can solve after we factor by setting our factors equal to 0 and solving for x. So for example, if we have x squared plus 5x minus 24, we have to make sure that the whole equation is set equal to 0. So everything has to be on one side, 0 has to be on the other side. Then we factor it up. Once we've got it in factored form correctly, we set each factor equal to 0 and solve. This is called the zero product property, and we use it a ton. So let's take a look at example number 2. First thing that I notice, 2x squared minus 9x minus 3 equals 2. First thing that I notice is it's not set equal to 0, so we need to take care of that first. So I'm going to subtract 2 from both sides, and I get 2x squared minus 9x minus 5 equals 0. So because this is a section where we know we can factor, I'm positive that this could be factored. If I don't love factoring and I see that it's a quadratic, or if it can't be factored, I could use the quadratic formula, but in this section, we're just focused on factoring. So I'm going to go ahead and open up 2 sets of parentheses. I'm going to set those 2 sets of parentheses equal to 0 because now I have my equal sign. It's an equation. I can solve it. I'm going to put 2x up front, x behind. If you have a different way of factoring, that's fine. I just find guess and check to be the most efficient. I know my factors of 5 are 1 and 5. So I'm going to try the 5 with the x. I'm going to try the 1 with the 2x. I'm going to use subtraction with this 5. I'm going to use addition with this 1. And I'm going to do a real quick check. If I have 2x minus 5, I get negative 10x. If I have 1 times x, I get 1x. And if I add those together, I get negative 9x, which matches what I have in the middle here. So I know I am good to go. So definitely check when you're using guess and check. Otherwise, you're not going to solve correctly. Once I've factored, I'm going to set these factors equal to 0. And then I'm going to find my 2 solutions. So I'm going to subtract 1 from both sides on this one. 2x plus 1 equals 0. 2x equals negative 1. Divide by 2. And I get x equals negative 1/2. That's one of my solutions. I'm going to add 5 to both sides. I will take shortcuts in the future. Normally, I would just say x equals 5 here, but I want you to understand that that's what we're doing. We're adding 5 to both sides. So x is equal to positive 5, and then I have my 2 solutions. For today, we're going to use solution sets so you understand what they look like. A solution set says x is equal to, we open up those curly braces, and we put it in order from the smallest solution to the largest solution, and then we close up those braces. So for today, we're going to use solution sets as our final answer, just so you know what those look like. All right, example number 3. X to the 4th minus 6x squared plus 5 equals 0. This is not a quadratic, so I wouldn't be able to solve it using the quadratic formula anyway. So factoring is going to be my go-to here. I do notice that it's set equal to 0, so I'm going to open up 2 sets of parentheses and see if I can guess and check my way into some factors. So I have x to the 4th. In order to split that up equally, I want to say x squared and x squared. If I multiply x squared times x squared, I get back to x to the 4th. I notice that my last factor is 5 again. So 1 times 5 are my only choices. I'm going to have to decide where to put those. And I also notice that I'm adding to get negative 6x squared. So I know I'm going to need a negative 5 and a negative 1. And honestly, it doesn't matter where you put that negative 5 and that negative 1 because we have this understood 1 up front here. So it's not going to matter. I am going to check it. Negative 5x squared is negative 5x squared. This is negative 1x squared. If I add those two together, I get negative 6x squared, which is where I want it to be. So again, guess and check. Do a mental check. I'm just showing you that that's what that mental check means. Once I have that taken care of, I'm going to go ahead and set both of my factors equal to 0 and solve for x. So I have x squared minus 5 equals 0, and I have x squared minus 1 equals 0. And it turns out we're going to be solving by square roots here, so this will be familiar when we get to that next section. I'm going to go ahead and, if I'm solving with a square root, I need to get my square root isolated. So I'm going to add 5 to both sides, and I have x squared equals 5. In order to finish solving this, I'm going to take the square root of both sides. And x is equal to, please don't forget that plus and minus. Whenever I take the square root of something, it can be positive, it can be negative. So plus or minus the square root of 5. That's one of my solutions. I'm going to go ahead and do the same thing. Well, this one I might treat a little bit differently. I know that x squared minus 1 is the difference of perfect squares. I could do this using square roots, or I could say I know that x plus 1 equals 0 and x minus 1 equals 0, that those are my two factors. So x is also equal to plus or minus 1. I'm using solution sets today, so x is equal to, when I use a solution set, I always want to go from my smallest to my biggest answers, my biggest solutions, my biggest roots. So I'm going to start with negative square root of 5, negative 1, positive 1, and positive square root of 5, and I'm going to close up that solution set. All right, number 4. Number 4, I've got x squared minus 49. I'm going to go ahead and use difference of perfect squares, but again, this one could be used because we have that square root. We could use a quadratic formula, we could use square roots, or we could factor. I'm going to go ahead and just factor. I know my factors of x squared minus 49 is x minus 7, x plus 7 equals 0. I'm going to set both of those equal to 0, and then I'm going to solve for x. Now here's where I'm going to start taking a little bit of a shortcut. I know that 7 minus 7 is 0, so x equals positive 7 and x equals negative 7. Those are my two solutions. So for my solution set, I'm going to say x is equal to negative 7, positive 7. All right, number 5. Always look for a GCF beforehand. I'm looking at 5x squared minus 20x equals 0. Luckily, it reminded me to look for GCF, or I might have missed it, so don't miss it. I noticed that I have 5x squared and I have 20x. I've got an x in both, so I can for sure divide out an x, but I could also divide out a 5. So I'm dividing out 5x from both. That means that has to come with you when you're factoring. 5x squared divided by 5x is just x. Negative 20x divided by 5x is negative 4. And that equals 0. So I do have two factors here. 5x equals 0 and x minus 4 equals 0. So if I divide both sides by 5, I get x equals 0. So it's not, there is a solution there. It's x equals 0 and the x equals positive 4. So my solution set is x equals 0, 4. Right? Number 6. I have 0 equals, so it's set equal to 0 already. 0 equals x cubed plus 2x squared minus 7x minus 14. So I have a 4-term polynomial, a quartic polynomial, a cubic polynomial. Gotta get my names right. And there are no greatest common factors, so that means I need to factor by grouping. So I'm going to group this up. I'm going to divide out the greatest common factor of the first binomial, which is x squared. And as I do that, I'm going to start rewriting this. 0 equals x squared. And then I'm going to open up my parentheses and put the answer to that division in parentheses. X cubed divided by x squared is x. 2x squared divided by x squared is plus 2. So this is the twin that I'm looking for, x squared. So I'm going to go over here and say, well, I have negative 7x and negative 14. I want to get a positive x and a positive 2. So I'm going to divide out a negative 7. That goes front of my second set of parentheses. I end up with x plus 2, which is exactly what I wanted. I wanted those twins. So now I have 0 equals x squared minus 7. That's one of my factors. And times x plus 2. If I were to multiply that back out, I would end up with what I started with. Our goal today is to solve, so I'm going to set both of these factors equal to 0. X squared minus 7 equals 0. X plus 2 equals 0, and I'm going to solve for x. I'm going to add 7 to both sides, solving by square root. X squared equals 7, square root, square root. Those square root cancels out the squared, and x is equal to, don't forget the plus or minus, square root of 7, and plus or minus square root of 7 can't be simplified. Sorry, I don't want to put a box around that. That's not my final answer right now. And then x equals negative 2. So I'm using solution sets today. So I'm going to say negative square root of 7 because that's smaller than negative 2. Negative 2, and then square root of 7. That's my final answer for today. All right. There are a lot of examples today. I do apologize. This is a really big deal. This is where like the math starts to become very, very different, and a lot bigger problems, a lot more to do. All right, number 7. Sometimes, occasionally, they will give you the factors and you won't have to actually do any factoring. So right now we have 2 factors, x minus 5 and 3x plus 8. They're already set equal to 0. So my only job is to set each one of these factors equal to 0 and solve for x. So they did a lot of the work for us, which is nice. So I get x equals positive 5. And I don't shortcut when I don't have a 1 in front of my x. I don't shortcut this because I tend to make silly mistakes. I would suggest that you don't shortcut it either, because if you miss a negative, if you say negative 3/8 instead of negative 8/3, it is wrong. So I have my 2 solutions. I'm going to put those in a solution set. Starts with negative 8/3. Goes to 5, or doesn't go to 5, but includes 5, and that's my final solution. 2 solutions. All right, and this last one for factoring, I have negative 8 squared plus 32 equals 0. It is set equal to 0. That's the first thing I check for. Second thing I'm going to check for is, are there any greatest common factors? Turns out there are. So with negative 8 and positive 32, I want to factor out the negative 8. I do not want a negative. I need to factor out any negatives. So I'm looking at positives, leading coefficients inside, or leading terms inside those parentheses. So negative 8, x squared divided by negative 8 is just x squared. 32 divided by negative 8 is negative 4, and that equals 0. If you don't recognize that that is a difference of perfect squares, it's okay. Once you put those equal to 0, you'll figure out that you need to solve it anyway. But right now we have 2 factors. I have negative 8 equal to 0, which is not true. So that's not a solution. We just say negative 8 doesn't equal 0 and move on. I also have x plus 2 equals 0 and x minus 2 equals 0. So that's how my difference of perfect squares factored out. So x equals negative 2 and x equals positive 2. I can put that in a solution set. Just be careful, watch for greatest common factor, watch for difference of perfect squares, make sure you take your answer all the way to x equals, not x squared equals. All right, so that's solving by factoring. The second way we're going to solve polynomials today is solving with square roots. Our method for that is to isolate that x squared and then take the square root of both sides. Make sure that you don't forget the plus or minus. Whenever we take the square root of both sides, we have a solution that is both positive and negative. And also, if you can simplify a radical, you have to simplify the radical. That's why we did that warm-up today. All right, we're going to start with example number 2. X squared minus 6 equals 0. I'm going to go ahead and isolate my square root. I'm going to add 6 to both sides. I have x squared equals positive 6. The only thing left to do is square root both sides so I can get x alone. X is equal to plus or minus the square root of 6. The square root of 6 does not have any perfect squares embedded in it. So I am done. X equals negative square root of 6 and positive square root of 6. All right, number 3. I have x squared minus 75 equals 0. I'm going to add 75 both sides. I get x squared equals positive 75. My next step is square root both sides to get x alone. And x is equal to plus or minus the square root of 75. Now I need to pause here and I need to think about, could the square root of 75 be simplified? Yes, it needs, we need to simplify, sorry, not needs to simplify, we need to simplify. So if a radical can be simplified, we have to recognize that and take care of it. So the square root of 75 can be broken up into a perfect square of 25 and 3. So the square root of 25 times the square root of 3 does equal the square root of 75. So they're equivalent, but I'm breaking it down so that I can simplify. The square root of 25 simplifies to 5, so 5 square root of 3. And if you were to put these two in a calculator, the square root of 75 and 5 times the square root of 3, they would give you the exact same answer. But this is what we need. So x is equal to plus or minus 5 square root of 3. X is equal to negative 5 square root of 3 and positive 5 square root of 3. And again, I'm just showing you solution sets today. Tomorrow I will probably skip those, but I want you to know that those exist, that we can see the individual answers and how many answers we have very clearly. Number 4, 2x squared minus 40 equals 0. Because I'm solving using square roots, I want to get the square root isolated first. So I'm going to go ahead and add 40 to both sides. There are other ways to solve this equation. I'm just using square roots right now because that's the method we're looking at. I'm going to divide both sides by 2. And I get x squared equals 20. So you might have said, well, why didn't she factor out a GCF? I could have done that, but with square root method, we don't have to. We don't need to. So x squared equals positive 20. I'm going to take the square root of both sides, and I get x equals plus or minus the square root of 20. I'm going to pause here and think, well, could I simplify that radical? Well, let's take the square root of 20 off to the side and see if we can break that up into any perfect squares. So it turns out the square root of 4 times the square root of 5 still equals the square root of 20. The square root of 4 is a perfect square, so 2 square root of 5 is equivalent to the square root of 20. So x is equal to negative 2 square root of 5 and positive 2 square root of 5. And that would be my final answer. All right. Phew. The last method we're going to use for today is solving using the quadratic formula. So we can use the quadratic formula instead of factoring. Usually factoring is easier and it also has less places for you to make mistakes. But 2 things. The equation has to be equal to 0 before we use the quadratic formula. And we have to be really careful. So the section under this radical is called the discriminant. We do have to simplify the discriminant before we take care of anything else, and I'll show you that. And we just have to be careful. So quadratic formula, I have a little song and I'd sing it for you in person, but I can't, so I'll sing it here. X equals the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. That's how I memorized it, so yay. All right, so I have 2x squared minus 4x minus 8. This is a quadratic. It's x squared. And it is equal to 0. So it's ready to go. It's ready to use the quadratic formula. I do not need to any greatest common factors. I just need to go for it. So I'm going to go ahead and do that. Here's how I use the quadratic formula. I identify my A, my B, and my C. So A is 2. This is written in standard form. It goes x squared x constant. B is that middle term, that -4, and C is that -8. I want to be really careful with my positives and negatives. And then I just start the quadratic formula. X equals the opposite of B plus or minus the square root. And I'm really careful here. B squared goes in parentheses, always, minus 4 times A times C, and I'm being really careful. I have to simplify underneath the radical without a calculator. All over 2 times 2. All right, so the first thing that I'm going to do is I'm going to simplify underneath this radical sign. So I'm going to go over, I'll do it down here. So I have -4 squared, that is a positive 16. And I have minus 4 times 2 times -8. So I can multiply -4 times 2, that's -8 times -8, that's positive 64. So right now I've got the square root of 16 plus 64. Be really careful with your negatives, which is the square root of 80. I'm going to go ahead and simplify that radical because what I notice is I've got an 80, and I want to try to figure out if there's any perfect squares in there. So I could say 4 times 20. That works, but I also just happen to know that 80 can be divided by 16 evenly. So 16 times 5 is 80. So I've got the square root of 16 and the square root of 5. If I multiply those, it's 80. If you didn't know that, you just continue with 4 and 20, and you would get to where I got to. So the square root of 16 is 4, square root of 5. You just have to make sure that that equals the square root of 80, but you won't have a calculator. So there's a little bit of mental math going on too. So x equals 4 plus or minus, I'm going to use that 4 square root of 5 divided by 4. I'm going to go ahead and break this up so you can see kind of what that really looks like. I've got 4 divided by 4 plus 4 square root of 5 divided by 4. When I say it's divided by 4, every single term is divided by 4. So I can continue simplifying. X is equal to 1 plus, and then 4 divided by 4 is 1 plus, plus or minus the square root of 5. So I do have two solutions there. If I'm writing it out as a solution set, I'm going to say 1 minus the square root of 5. That would be the smaller of the two solutions, and then 1 plus the square root of 5. And that's my final answer. All right. Number 3. Good news is we're almost done. I have x squared minus x minus 7 equals 0. First thing I'll always do when I see a quadratic is I will try to factor it because it is faster and easier, but this is not factorable. So a equals 1, b equals -1, and c equals -7. That's my strategy to get started, is make sure I know what my a, b, and c are. And then I just start with my little song. X equals the opposite of b, so the opposite of -1 is +1, plus or minus the square root. I always put my b squared in parentheses, minus 4 times a times c. And I probably didn't need to write that 1 here, but I did, so no big deal. And then 2 times 1 is just 2. I'm going to simplify underneath the radical sign, very first thing. So over to the side, I'm going to say negative 1 squared is positive 1. And then a negative 4 times positive 1 is negative 4. Negative 4 times negative 7 is 28. So I really have the square root of 1 plus 28, which is the square root of 29. 29 is a prime number, so 1 times 29, there's no way to simplify that, so I'm good to go. So I'm going to say x equals 1 plus or minus the square root of 29 divided by 2. If I know that 1 can't be divided evenly by 2, so there's no way to simplify 1/2, it's just 1/2. And I know that there's an understood 1 out in front of that square root of 29. I can leave it just like this. So I don't have to break that up into anything crazy. I can just say x is equal to 1 minus the square root of 29, all divided by 2, or 1 plus the square root of 29 divided by 2. I could also break that up into x equals 1/2 minus 1/2 square root of 29, but you can see that that could be really messy, and I don't think I would bother to do that. It's just if we need to simplify those fractions, we have to. All right, and then the last example for today, and then you'll be able to get to work. 4x squared plus 7x equals negative 2. This one's not set equal to 0 yet, so I need to make sure I take care of that. I'm going to go ahead and add 2 to both sides. 4x squared plus 7x plus 2 equals 0. So a is equal to 4, b is equal to 7, c is equal to 2. So x is equal to the opposite of b, so positive 7, I make negative 7, plus or minus the square root of b squared. I'm still going to put it in parentheses, even though it's just a habit. Minus 4 times 4 times 2. So 4 times a times c, all over 2 times 4, which is 8. I'm going to take care of the discriminant first. So I'm going to go over here to the side, do a little bit of mental math. 7 squared is 49. And then it is just straight up subtraction because I have no negatives in the 4 or the 2. So 4 times 4 is 16 times 2 is 32. And I can continue to simplify that further. 49 minus 32 is 17. 17 is another prime number. I can't simplify the radical. So x is equal to negative 7 plus or minus the square root of 17. I'm going to replace that whole mess with the square root of 17 divided by 8. And again, because 7 can't be divided evenly by 8, there's no common factors, and there is an understood 1 here, I could write that as negative 7/8 plus or minus the square root of 17 divided by 8. It's easier and cleaner to leave it the way it is. So x equals negative 7 minus the square root of 17 divided by 8. That's one solution. And negative 7 plus the square root of 17 divided by 8. Solution set. It shows two clear solutions, and we can see exactly what they are. Alrighty. So I have for you now, please make sure that you did the warm-up. You need to submit a picture of your notes to the assignment in Canvas. You have your homework assignment. I don't have any additional assignments for you today, just homework. Please show your work on paper like you would on a quiz. Most of the tests and quizzes that we have moving forward are all paper pencil, so there won't be multiple choice. You need to start showing your work. And we will have that Unit 3 quiz on Monday. All right, have a great day. Email me if you have any questions or concerns.